Did you know that you can't actually just keep adding more and more steel rebar to your concrete structures to make them stronger? To understand why an over-reinforced concrete beam would still fail, we need to look at how beams would act under loads and how that would interact with the concrete and the rebar. In this diagram above, we can see the deformed shape of a beam under a simple load, and we can see that the top part of the beam is shortening and the bottom part of the beam is extending. So that means the top part of the beam is forming compressive stresses and the bottom part is forming tensile stresses. This is important to know because concrete is strong in compression, but extremely weak in tension. So to counteract this, engineers will place the steel rebar where the tensile stresses are expected to form. Now, in designing these members, we actually section off a compression zone, which is going to be the area of concrete that fully resists those compressive stresses, and then the steel rebar is going to fully resist the tensile stresses. This means that if we were to keep adding steel rebar, all we'd be doing is changing the failure mode from the steel yielding here to now the concrete crushing, which would lead to a very brittle failure, meaning there'd be almost no warning that the concrete member is about to fail since concrete fails so suddenly. Here's examples of both of those failure modes, where on the top we can see a properly reinforced concrete beam. You can see some flexural cracking and it's failing in a very ductile manner where it's giving you a lot of notice. And on the bottom we have an unreinforced concrete beam just to illustrate how concrete would fail on its own, where you can see there's almost no cracks in sight and it's a very brittle failure and very sudden. The concrete building code recognizes the difference in these two different failure modes by requiring us to apply a high strength reduction factor to our compression controlled section. As you can see in the graph below, if it's determined through analysis that the steel is going to strain a small amount, that'll put us in the compression controlled region, which means we have to apply a strength reduction factor of 0.65. And that basically means we can only take 65% of our member's nominal capacity. Whereas if it's determined that the steel is going to strain a lot more and give us a ductile failure mode, or what we call tension controlled, then we're allowed to use a strength reduction factor of only 0.9, which means we can take 90% of the member's nominal capacity. In concrete design, we also have maximum reinforcement limits to help remind us of this, but at least now you know the physics behind it.